Hi everyone, we're going to take a look at how to draw a pentagon, which actually contains the golden ratio, or the number phi, in it. So let's take a look at how to do that. It's a little bit more complicated than 6 sides, but it's really not that hard. We start off with a circle, and then we're going to need to find the diameter, or cut a line through the circle, going through the center. So I like to place my pencil there, then line up my ruler, put my pencil on the center, and I draw my diameter. The next step is we're going to construct the perpendicular bisector. So what that means is we're going to cut that line in half that we just drew. So I'm going to make my compass a little bit bigger than halfway, or what is obviously halfway, and I'm going to draw an arc on the top and bottom, go to the other side, and what that does is it finds the middle for us, or the perpendicular bisector, because it not only cuts it in half or bisects it, it's also going to make 90 degrees. So now there's just a couple more steps. It's really not that difficult. We want to find the same thing we just did, the perpendicular bisector, halfway. We want to find halfway between the half we just found, or the radius. So we'll do that. And that will help us to find the midpoint of the radius, right there. So I'm going to connect that to the top, and we could take a second to look at what we have here. Even though the radius is like 1, we're using half of it here, so I'm going to call that 1. Here we're using twice as much, right? We're using the radius would be 1 and 1, so then here would be 2. If we use our Pythagorean theorem, we get 1 squared plus 2 squared equals the hypotenuse, this line, and we would get the square root of 5. So this line we're going to be using represents the square root of 5. So what we're going to do is we're going to measure that line out, and we're going to repeat that over here and draw the same length. So the length from here to here is going to be what we're drawing from here to here. So we have that same amount of square root of 5. In fact, since this was 1, this would be like, we said really it's half. So this is half the radius. So we can divide everything by half. So what we really have here, we can look at it a little bit later. This line here would be the square root of 5 over 2, and this line here would be 1 over 2. So square root of 5 over 2 plus 1 over 2 is the golden ratio, phi. But that's not our finished product, so let's finish our pentagon. So we're not actually using that line or that line, but what we have is a distance, which is really what we're looking for. The distance from this new spot to here, I'm making orange. So this is now going to give us 5 equal orange lines all the way around to make a pentagon. So I'm going to basically copy that length, or that amount. So I could use my compass to measure it. It would be this amount, and begin to use that to make my markings for my 5 sides. 1, 2, 3, and of course you really want to be careful and more accurate. I'm trying to do this a little quickly, and so you see I'm a teeny bit off, but if we do this on a computer, or we do this more carefully, where I'm not rushing to show this in the video, we're going to get exactly 5 equal amounts. So then I can draw here to here, here to here, here to here, here to here, and here to here. So let's take a moment to look at the other ways we find the number phi. If we take the longest distance between 2 points, which would be here to here, and we divide it by any of the equal sides, I'll make it here purple, that brown divided by that purple is going to give us the golden ratio, phi. we could continue to connect each of the lines to make a pentagram. And I want to do that for a second just to show you another spot we have the golden ratio. So another spot we have the golden ratio in would be from using the 5-sided star or the pentagram. We're ignoring this orange line. This amount in the star divided by the little piece in the middle also will give us the number 5, or 1.618, the golden ratio. So the Pentagon, even though it doesn't show you the Fibonacci spiral, contains the mathematics or proportions of the number 5. And of course we see this shape in lots of places in nature, the blackberries and raspberry buds, orange and grapefruit buds, and many other different plants and vegetables. Even a papaya has a 5-sided star inside. So that's how we would make a pentagon and some of the mathematical properties behind it.